Hi, this is Umbraco Performance Tuning. I'm Shannon Deminick. I work at Umbraco HQ. You can find me online at Shazwaza is my Twitter handle, and shazwaza.com is my website. I get this question asked quite often. How many concurrent users can Umbraco handle? Well, this directly translates to how many requests per second can Umbraco handle, which then translates to how many requests per second does your website actually need to handle. Finally, that translates to how many requests per second can you make Umbraco handle? At the end of the day, it comes down to Umbraco implementation, which is done by you, and that really dictates how many requests per second or throughput your website can achieve. So to measure that, you're going to need some tools. It's super important to do this measurement if you think that throughput is important or if your clients think it's important. Once you get used to the tools, then you know exactly how much throughput you can actually achieve. There's about, 3 dozen different load testing tools out there, probably more. They all come in various shapes and sizes, and they all have different features. So you need to pick the one out there that best suits your needs. Some are paid, some are free or a hybrid of both. Some are cloud-based, which is important for a lot of folks if you want to have realistic-based statistics and testing against your website. Preferably, you do that testing against an environment that you're actually going to be running on. Some people might need a tool that runs locally because it's handy just for local testing and quickly figuring out how fast or slow pages are. And then the types of reports are also important. Maybe you want markdown output so you can copy and paste that in. Maybe you want some fancy graph output, or maybe you want to stream those statistics directly into some back-end data engine like Datadog. It really all depends. Each tool has its own features and benefits, so you'll need to pick the one that's best for you. At the end of the day, though, any tool is better than no tool. Once you've run these tools against your site and you discover that it's a bit slow, what are you going to do? So we need to figure out how to isolate those issues. One thing a lot of people do is just chuck some more money and hardware at it. So it's slow, why not just scale out? I'll just use the Azure toggle and go to 100 instances and see if that handles it. Oh, it doesn't. Maybe I'll up my database instance to something more expensive, or maybe I need multi-regions or all sorts of things. And although this might work temporarily for some things, it's going to cost a lot of money, and it generally doesn't scale well if there's a fundamental issue with the code that's performing badly. So to isolate an issue, we're going to need some more tools. We need to figure out what kind of issue we've got. Is it SQL issue? Is it a memory issue? CPU issue? All of the above. To figure that out, there's various tools that we can use. One's actually built directly into Umbraco, which is called Mini Profiler. There's also memory profilers and performance profilers, and some examples of those are like Visual Studio Enterprise, Redgate, and JetBrain make tools for that. SQL execution plans are important to diagnose SQL issues. You can run these directly in SQL Management Studio. What that will tell you is exactly how one SQL statement is executing, whether you're missing some indexes or indexes can be optimized, whether it's doing index scans versus seeks, and how much time it's spent in all of those scenarios. And the last one, there's more ways you can measure these things, but these are some common ones. The memory dump analysis is probably a bit more in depth than the rest of them, but you can get memory dumps from Azure or from your computer, and to look at those, you'll need tools like WinDBG, which is a very old tool. There's a new one in preview, which has been in preview for years now. It looks a bit nicer, and there's also other ones called DebugDiag, and you'll find more online. If it comes to that, hopefully you don't have to jump into memory dump analysis because it's a bit complicated. But if you're good at it, you can find some very interesting things. So let's jump into mini profiling, just see how that works. So this is shipped with Umbraco. So this screen is quite busy, so we'll start from the top. Number one, to enable Mini Profiler, we're going to add an debug equals true query string to any page. This also works in the back office just fine as well. The important thing to note, though, is this won't work unless debug is true in your web.config. So the number 2 point there is showing how long this page took to execute. So 1.3 seconds or so. And then the third part, when you click on that button, it will bring up all of the steps that are significant. In this example, this was just profiling the startup. So startup took about 1.2 seconds, and during that startup, you can actually see that it executed 5 SQL statements. We can actually go ahead and click on that, and it will then show you exactly what SQL statements it executed, so you can go debug all of those things. This is actually quite handy for debugging any performance issues in the back office too. In this case, in this example, you can see one of the SQL statements executed was just to see if Umbraco needed to upgrade or not during startup. So how do we isolate an issue with Mini Profiler? Let's have a quick look. So on the same screen, in the top corner, we see that this page has taken 4.3 seconds to render, which is a pretty significant amount of time. The screen's a bit small, but if you hover your mouse over each one of those steps, it'll actually show you the source of where those steps are coming from. So in this case, top navigation might be taking a bit of time. So let's have a quick look at what that is. Well, just having a quick glance at this, we can see a few things going on that's going to cause things to slow down. First thing that's obvious is there's a weird thread.sleep. How'd that get there? Well, I guess maybe a developer might have been testing and accidentally committed that. So that's definitely something that we can fix up. And then, looking around this code, we can see a few other interesting things, like we're calling model.root 4 different times when we could easily have just stored that into one variable and reused it. Then we start getting into some trickery with IEnumerable. So here we're saying if children.any, and then we're going to iterate over those children. Well, there's no point in calling if children.any because it's not going to iterate over those children if there aren't any in the first place. The other more interesting thing here is IEnumerable is like a lazy execution. So what's happening here is we are reiterating children a whole bunch of times. So as soon as we say if children.any, it's going to execute this where clause and going to iterate over all children until it finds one, which is going to allocate a few iterators. Then we're going to re-enumerate children again, which is again going to execute this LINQ query. So there's a whole lot of stuff going on here that's a bit subtle that we don't really need to do. And when we talk about critical code, we're talking about code that executes all the time. In this case, if it's navigation, it's probably going to execute quite often, every single page. And if you're looking through throughput, you can see that that's going to have significant overhead for all of your users. So you want to make critical code as fast as possible. Another one here is that for each item that we're iterating over, we're doing this extra call. This is sort of an n+1 issue. So we're going to check if the nav item is active for that one item. Well, we don't need to call isAncestor for every single child if it's active. Once one is active, we don't need to check the rest. So we can actually optimize this a bit more. So with the optimizations done, let's have a look at the top part. We now store model.root into a variable. We've removed our thread sleep, which is good. And we've created a new variable called active link, which we're going to use to check whether the link is active below. The fourth part here is that we're just reusing the site variable that we have stored again. So now we're only calling model.root one time. And then this is the below script. So the first one, we've taken out the any check because we don't need it. We're going to iterate over the children, and we're going to check if the active link has been set. And if not, then we'll call isAncestor. And if that's true, then we're going to set the active link to true, which means we only check isAncestor one time. And then we just say, is this one active or not? And away you go. So this can save on a bit of overhead. So talking about those APIs there, there's been a lot of talk throughout the years with Umbraco APIs, especially with V8 and V7, is did we make them a little too simple? Because with the Umbraco published content APIs and LINQ, it's a little too easy to shoot yourself in the foot. So iPublish content is both a service and a model. This is just based on legacy, and it's something that we need to deal with. It'll be post V9, so maybe V10 even, but this needs to be split into two things, a service and a model. By doing this, it makes it actually testable, because right now it's very difficult to test. It would actually clean up a ton of code, and it makes a clear separation of concerns. Better yet, what it would mean is for your front-end developers or people that are using published content APIs, it makes it very clear that an execution or operation is taking place, because right now it's not very clear at all. And there are some examples here. So every time you execute any of these methods, it's like making a service call. Now, the published content cache is in memory, but it doesn't mean it's all for free. If you keep iterating and iterating over all sorts of collections, your performance is going to degrade. So anytime you call model.children, that's basically a service call. It's going to allocate a bunch of objects and some background iterators. Same with model.ancestors, descendants, siblings, root, and all the friends associated with those calls. It's very easy to use these calls in LINQ, which also makes it a little bit dangerous. Same with property access. So anytime you do model.value or model.url, these aren't free either. And quite often we see in code reviews that all of these methods over and over and over again keep getting called for the same exact property values and parameters, whereas they should only be called once and then that variable be stored. Behind the scenes, it's not doing anything smart. It can't really do some magical caching or anything like that. These are just service calls. So in the future, if we make these more transparent that something's actually happening, it would make it very clear for developers to not keep calling these over and over again. So LINQ, as I mentioned, can be problematic. So one note I've got here is IEnumerable is not iQueryable. If you've used Entity Framework and other things like that, iQueryable is basically looks like IEnumerable, and you use LINQ statements just like you do with iPublish content, but behind the scenes, it compiles a query, an efficient query, and then it executes it. The published content cache is not iQueryable, it's IEnumerable, which means anytime you do a where clause or an any clause or a first clause or anything like that, it's going to enumerate that collection. So here's an example with LINQ. If model.children.count greater than 0, if that's the case, we're going to go get a navigation item, right? So that seems simple enough, and that can't cause any problems, but let's have a look at what's actually going on. So count here, count bracket bracket, is going to be called an IEnumerable. So in order to get the count of children, it means it's going to have to visit every single one of those children. It doesn't know the count until it visits them. So it's going to create an enumerator, and it's going to enumerate all the children just to get a value, and then check if that value is greater than 0. Singular default. This also seems safe, but in fact, it's the same as count, right? In order to find of whether something is only a one item or not, it has to enumerate the entire collection. So again, it's going to visit every single descendant of the model just to find that one item, and then validate that there is only one item. And then there's a problem with descendants of type, or any of the descendants calls, because behind the scenes, I mean, that's going to enumerate the entire tree from there down. So every single item. So how do we fix this? Well, there's a lot of different ways we can do it, but some simple ways, and just to understand what's happening is, if I do .any on children, it's going to create an enumerator, but it's going to exit that enumerator as soon as it finds one. So that's much more efficient than enumerating every single item in the entire collection. The second one is first or default is much better than singular default. And a lot of people don't realize this, but first or default is kind of just like any. So it's going to enumerate the collection until it finds that first one, and then it's going to stop enumerating it. Whereas if you call singular default, it has to enumerate the entire collection just to validate that there's only one. And then the last thing that we can get rid of, let's try not to ever use descendants at all, if possible. In some cases, maybe that's fine as long as you know how many descendants there are. But generally speaking, it's not the greatest API because it can cause quite a lot of headaches and you're visiting a lot of items in memory. So let's simplify this a little bit. We'll just do has children equals children.any, and now we can reuse that. Too often I see model.children.any used, 4 or 5 times in the same view, and then some. Store the output of all these methods. Don't keep calling those same methods over and over again. And then what people keep forgetting, or maybe it's just like it's old school or something, but it actually works really well. If you get content by its ID, there's no overhead because the in-memory cache is just a giant dictionary. So there's no harm in storing your ID, maybe a GUID, maybe an int, just put it into your configuration if you want, because if this is critical code and you're going to look up your navigation every time, it's so much faster just to say, get me this content by ID, and then you're done, right? There's no overhead anymore. So some other tips. I got this quote from this actually amazing blog post. About 60% of the human body is water. Similarly, about 70% of a .NET application is strings. This is true if you've ever used memory profilers, and I highly recommend reading this blog post. It's actually fantastic. So one tip is avoid allocations, and strings are the biggest one. If you ever open a memory profiler and analyze an application, strings are always the top of the list, the top of your memory consumption there. Now, what's wrong with allocations? Well, allocations are the things that you see in a memory profiler. They're objects on the heap. And things that go on the heap have to be cleaned up by the garbage collector. Well, the garbage collector is not free. It actually works quite hard. So the more stuff you've got in memory, the more it has to clean up. The more stuff that goes in and out of memory quickly, the more it has to clean up. And this is called GC pressure. So the larger objects you go in stay in memory a bit longer, the smaller get cleaned up quicker. But at the end of the day, more memory means more CPU time. So what can we do about it? I mean, there's tons of blog posts you can read about limiting allocations, but it's important to start realizing what these are. So strings is a big one. If you're doing string concatenation, remember that a string can't be mutable. So every time you concatenate a string, it's going to create a new string. That means allocating a new object again. You can use string builder for larger concatenations. Using string builder for really small ones actually doesn't work as well as you think. Some simple tools like setting capacity for collections. So when you create a new list, there's an option to set its capacity. If you know it's going to be, less than 10, make it a 10 capacity. That means when it's dynamically resizing by default, whenever that does that, it's going to create more and more memory. There's some other tools like pooling with array pool. If you want to read up on structs, if you don't know what they are, structs don't get allocated to the heap, they get put on the stack. And they just need to be very small. So, integer is a struct, all those base level types are structs. You can create your own structs as long as you're careful about it, but this really can significantly save on CPU time and memory overhead. Span T is a new thing in .NET Core. I'm not going to cover that here, but you should definitely have a look at it. It does allow you to basically analyze in-memory objects like strings without having to create new instances of strings. Another tip is to be lazy. Perceived performance is very important. So what perceived performance is if a user loads up a site and it happens quick, but there's still stuff that goes on in the background that they don't know about, that they don't know about it, and that's great. So they perceive the performance of your site to be fast, and that's good. So the more logic that we can defer, the better. So avoid eager operations. I see a lot of code that performs logical operations in a class's constructor. You should definitely try to avoid that at all costs, because you have no idea when that thing is going to be created. So there's some helper utilities you can use. Lazy T has been in .NET Framework for a long time, and same with Lazy Initializer. So have a look at those, and yeah, be a bit lazier in your code and try not to eagerly execute things. And here's a challenge for you. Try not using LINQ at all. We talked about critical code before. A lot of people will have rules set up where if it's critical code, you're not allowed to use LINQ. And if you try not to use LINQ, you'll notice that you end up probably only iterating a collection one time instead of by accident, maybe 10 or 20 times. So if you want to challenge, try not to use LINQ and see how you go. I know LINQ is very easy and it's good, so I'm not saying don't use it ever. I'm just saying for critical code paths, try not using it. So partial views, I see this so often. The same logic embedded in so many different partial views, and that might be because different developers edit those partial views, and that's fine. But the more you do the same thing over and over again for the same rendering, the more overhead there's going to be. So how do you fix this? Well, the right way is to do all of your logic in controllers. Create your own view models, pass those view models to your views, and then have those views pass the submodels to your partial views, so all the way down. So that means that your front-end devs are only working with a strongly typed model that you've created and populated for the entire page in your controller. And in some cases, this might be difficult. I'm not saying it's super easy to do that way, but at the end of the day, it means that all of your lookup logic is in one spot, and then you know where your performance problems or solutions need to be. And like I keep saying, I keep seeing the same code over and over and over again in views. So just don't repeat yourself. This is super important. And it's an easy thing to do. Don't keep calling the same methods over and over and over again in the same view. Try not to call those same methods over and over and over again in other views or in your controllers. If you can be smart about code reuse, you will immediately gain performance. And then some people just say, no, I don't want to learn all this stuff. I'm just going to cache the view. Yeah, whatever. I'll just chuck some cache in front of it. It'll be fine. Well, caching should be used for amazing performance, not just, or not at all for fixing things. Because the problem with cache is cache turns over. And that's a very difficult thing to debug. And it can cause even worse headaches. So cache turnover happens because the runtime cache is like a time-based cache. It's not forever. Each item has an expiry. Policy is not guaranteed. It's not blocking. And by not blocking, what I mean is if your cache expires and you've got 100 requests coming in at the same time, those 100 requests don't wait for one request. They'll all hit the thing that is supposed to be cached. So your performance is going to go through the roof if that one thing performs quite bad. And then too much cache means no cache, because if you put too much stuff in the memory, it's going to exceed the cache limit, and then it's going to evict that cache again. And this is what is called cache turnover. So it keeps going in and keeps getting chucked out, which means you're going to put extreme amount of pressure on your garbage collector. So what can we do at the HQ and as a community? Well, the CMS can always be faster. So here's some notes on what Umbraco and the community are doing behind the scenes. We've got a version coming up. Don't know when, but I'm calling it 8.chad for now. Internally, we've called this Pied Piper for Umbraco, and I'll tell you why in a sec. So who is Chad? So Chad has been an active community member for a couple of years. He's doing some amazing work, doing a lot of profiling and performance tuning, you can check out his PRs on the Umbraco repo. He's on GitHub, and I can see he's got sponsorship enabled, so if you feel like buying Chad a beer or coffee, head over to his GitHub there. I'm sure you'd appreciate it. So what is 8-point Chad? Well, you can have a look at this PR. It's 8376, and it has a whole load of crazy stuff going on in here. Essentially, we use something called message pack with LZ4 compression, and we combine that with some new cache data. This is also why we call it Pied Piper, because of the compression. Chad's enabled a bunch of new database indexes that makes loading the new cache data from the database into memory way faster. And with that, we've also enabled SQL Server include index support. And there's also tons more. I mean, the list goes on. We've actually had to have this PR, and there's even more stuff in the pipeline from Chad once this gets all in there. Let's have a look at some stats, though. So the CMS content new table is what populates the in-memory cache when you cold boot. So when you cold boot, we don't read from the local files. We read from the database to create the local files. This will happen if Azure moves your sites or anything like that. But it's just amazing that with message pack, which is a binary serialization, so similar to JSON, but it goes to binary and it's much smaller and a bit faster. But our table size of this is reduced by about 73%, which is actually huge. So if you've got tons of data, this was a 15,000 rows, but the more data you have, the more benefit you've got of this. Now remember that this data gets transferred over the network too. So there's a network latency problem here. Like if you had 100,000 rows, the amount of data that needs to be transferred is quite substantial. So reducing this amount substantially reduces cold boot times. Speaking of cold boot times, this is before and after. So 18.5 seconds down to 5.6 seconds. So that's a 70% saving on performance for cold boot times. It's also far more consistent, because when I was doing these benchmarks, cold boot times before all of these changes would double that and then go back to 18. And then there is one other feature, which is in-memory compression of property data. Now, this is not enabled by default. It's more of a prototype. But what it means is you can implement your own iProperty cache compression options. And then you can dynamically make the in-memory property data compressed with the LZ4 compression. This can be useful for archive content or old content that maybe doesn't get visited very much to reduce the in-memory overhead. It does mean that there'll be some extra CPU to uncompress it when you're rendering. But it's pretty cool, so something to play around with in the future. And then lastly, we get into measuring our own CMS performance. And this is a tool I've been working on for a bit, taking some inspiration from benchmarks, which was a very handy tool and very nice to look at just to see what the overview of things were. But we didn't really know what was happening behind the scenes. So we've made a working prototype since benchmarks is no longer online. And this is open source. It's on GitHub. It's in the Umbraco CMS repo under a branch called feature load testing scripts. And, potentially we might move this to a different repository at some point. But it's a combination of PowerShell, Artillery IO, which is a load tester, Node.js, Cosmos DB for storing data, and Power BI for reporting on the data. And this tests across both .NET 5 and .NET Framework. So, of course, Umbraco V8 and 9. So there's some scenarios that are already created. Warm up, login load, create doc type, create content, update content, delete content, and then a front-end throughput test. These tests sort of rely on each other, so they need to execute in order. And there's more to come. So this is just the start of something cool. And the metrics that we record, this is for both .NET Framework and .NET Core. Percent CPU time, working set, and total committed bytes are sort of external to manage memory. And then we got Gen 1, Gen 2, and the large object heap size. And if you combine those all, that is the managed memory size. So I will show you some results. So here is CPU time by scenario. I'm not going to go into depth about each one, but I will show you what V9 looks like. Now, of course, lower is better, and you can see that that is substantially lower. So that says that V9 is definitely, absolutely much, much quicker. Now, this is the front end throughput. So this is overloading the front end, and this is all based on the starter kit homepage on all these versions. And again, V9, look at that. That's just mind-boggling how much faster that is than V8. Managed memory, we're pretty much on par. I know these figures look a bit skewed here, but managed memory is also hard to manage perfectly. But the main thing to note is we're looking pretty much average here with V9, which is expected because we haven't done any huge memory profiling. And then we've got response per second throughput. So this is also, again, the front end throughput. Have a look at V9. So, we're getting way past the response per second than we could with V8. And this is an interesting stat. So this is also a throughput, but for 99% of the users, the latency was X milliseconds or lower. And this is also like completely overwhelming the front end, and you can see that V9 responds much quicker than V8 when it's maxed out. So how accurate are these statistics? Well, they're fairly accurate, but the most important thing is that this is a measure between versions, not the actual raw numbers. So what's next? Well, this is just the start of something cool, but we need to do some more scenarios, and more importantly, we need to change the data sets. So test this against really large data sets, medium data sets, and small data sets, which it's currently testing on. And then finally, try to automate the heck out of it. So, I can click a button and then we'll run all day through every single version of Umbraco and chuck it up into our data store so we can report on it. But it's getting there, at least it's runnable, and we can report on it. So that's awesome. And that's the end of this talk, so I hope you enjoyed it, and have an awesome code garden.